So I will make a new little table tent that says, please take one. And in your notes or your toolkit, let's put a header for 4.2.1. Today we're doing proportional relationships. Reminder, Mr. Smith's breaking stuff. Reminder, your homework headers. Because as we move forward, the homework check is getting more and more particular. Need to have the section number, 4.2.1, the problems that you're doing, and the date. Those three things need to be in your headers for your homework. So some people, I've noticed, have started to fill in their headers when they sit down in class. They fill in their plan book, then in their math journal, they fill in the header for the homework that night. That'd be a really good strategy, so it's already done. And the assignment's already written down, so you don't even have to check your plan book. Makes sense to me. So, who's ever been to the grocery store and seen a price per pound? I eat bananas almost every day. Potassium's good for you, and fruit is just good for you. I could probably tell you that at most grocery stores, the price on bananas is between like $49 and $65 if you go really expensive. Cents per pound. But what if you're at the grocery store and it says buy 2 pounds of apples for $1.29? Think about how we could use that to figure out what if we want like not 2 pounds, but maybe like 5 pounds or 7 pounds. If we know 2 pounds, is there a way to figure out 1 pound or 3 or 5 or any other amount of pounds? Hopefully you're thinking to yourself, yes, there is a way. So that's what we're going to talk about. And if you tried the homework last night, you realize we are discussing proportional relationships. So now you probably wouldn't even know the answer to this question, but a lot of you likely have college funds. Money set away in the bank that the bank likes because they know how old you are and they know the normal rate for going through school. So they assume you're not going to touch your money for a long time. So Gustavo's grandmother set up a college fund for him. She says that the account pays simple interest, and now after 5 years, that's probably some important information, after 5 years, we can see the account. So you guys all have your resource page in front of you? Woo, my board needs oriented. So we have this resource page, right? Time after deposit in years. We are looking at this. So go ahead and mark that point right above 5 years. And if you trace it over and look at where it goes, how much money is in the account? $500. Gustavo says, well, shoot, man. 5 years, $500. 10 years, all of $1,000. Talk with your team on if you think what Gustavo's saying is correct, or if you think there's any error in his thinking, and why. You have to be able to back it up with some math. Okay, I know we took like a big old break with Thanksgiving and everything else. We're going back to random cards to see who can help me out. So talk with your team. Try to be ready to present whether you think he's right or wrong and why. So now is what we marked. The point we marked, we are 5 years into the investment. We are here. If you think he's wrong, I want you to predict how much he would have in there. Let's say she started the account when he was born. How much will be in the account? So Gustavo's doing math at 5 years old. I know. Just go with me. How much would be in the account after 18 years? Try to solve that real quick. You have another minute, see if anybody can solve that. 18 years. It's a challenge.
Alright, okay, so what I'm thinking here is that one year yeah, 1 year is 100. 5 years is 100. So
I didn't even see. Okay, fine. Go ahead and be selfish. Allie, what do you think? Is Gustavo correct that he'll have $1,000 5 years from now? No. Why? Do you know? Did you guys figure out? What?
no.
Okay, what's your idea? Yeah, anybody from your group.
Look at this first paper that we have. We can go to the bottom so that it goes up 10 years.
So I kind of made your lives easy by giving this to you from the get-go, but we can see it goes up to 10 years. If we know right now we're at 5 years, 5 years from now is 10 years, and we can see from the graph that's not $1,000. Sorry, Gustavo. Why, though? What was his error in his thinking? How could you explain this? Francesca?
He thought that it would start at 0 and it went up 100 every year, but it only goes up 20 every year.
Could you start a bank account at 0? You cannot. You technically have to. You could do like $1. Some banks will let you do just anything. Some have minimum deposits. You can't start with nothing. And you could take an account down to nothing. You could actually take it negative. Not a good idea. But if you're trying to get an account to grow, you got to start with some chunk of change that can then grow. Anybody know how much they started with here? What did Gustavo's grandma invest? Marvin? $400 was her investment, right? At 0 years, if you want to label on the sheet, this is 0. That's our start point. He had $400. So what we see is his growth to get to 5 years is how much? What did he make in 5 years? Or what did she make? Really, it's her money. $100 in how long? So how much did how much did the account make per year? If we want to make that denominator 1 for 1 year, we can either divide by 5 or multiply by a fifth, whatever you think about. But we do the same on top and bottom, or if you just do the division. You get $20. So then, we try that really challenging question. How could we figure out what would be in the account at 18 years? First question we want to answer is how do we figure out how much money was made? How do we figure that out? Keeps going down. Right?
How much money was made?
Yeah. If we're saying that it stays in there for 18 years. How'd you get it?
20 times 18.
If we multiply by 18, now is that how much is in the account? So, if we started with 400, what would be the total out there then?
800.
That 360 plus the initial 400, we would have $760. That might be enough for a quarter's worth of textbooks.
Awesome.
Not joking.
Yeah.
Textbooks are hundreds of dollars. So we went further than the question really answered, but good conversation.
Good morning, Gabby Please stop by the office. Gabby please stop by
further than the question we asked. Sorry. So we already know this, right? Gustavo is predicted to have $600. He figured out that he's growing at a rate of $20 per year. Please, if you did not get, let's make sure we get down something. If you did not get this down in your notes, the $100 for 5 years, please go ahead and get this copied. Sorry, it should be YRS. And then that's how we get the 20 for every 1 year. So let's say Gustavo wants to figure out if he takes it out at 8 years. Can you find account balance by just doing 8 times 20? Account balance. Can you find account balance? Like we just did 18 times 20. We had to do an extra addition, right? That extra addition is kind of annoying. This, the account balance is not proportional, although the growth in the account is how much money he makes. So when we talk about proportional relationships and we talk about the graph, this graph is not proportional because it does not go through the origin point. And we'll write this down in a minute. Proportional graphs have to go through the origin point, the 0, 0 point. All right, so let's look at. We kind of processed all the way through this. I wanted to go a little bit quicker today. Any questions on how we got that $20 per year? Yeah, we can either just do the division or set up the proportion and use like giant 1 type thinking. There's a few different ways to get there. It would be sweet if our money kept doubling, but that would be exponential. You don't need to know that yet. But if something continues to double or half, or you guys talked about half-lives in science? Okay, so everything that decays, and pretty much everything decays, has what's called a half-life. In what amount of time will it be half of what it was? Well, let's check out 25. I'm not going to give you any intro at all. With your team, look at 25 helping Sonia buy some birds. I'm not going to say anything else.
You guys are out.
Real quick, how much would it cost if you buy 0 pounds of birdseed?
0.
Okay, just checking.
Oh, wait. If it's 0,
By the way, please don't write in the book. That table's tempting to write in the book. Please don't. Okay, so go ahead and copy that table down. Table down at your leisure. So we worked a little bit quickly on the first couple problems so that you can have time on this one. Copy that table down. We're going to fill the whole thing in. Alright, we got real quiet. How we doing? You ready to talk about it?
Like 2 minutes.
How about one and then we'll start?
I'm thinking that 27.5 6.7. Just
Alright. So the first thing we get asked here is if Sonia doubles her amount of bird seed from 4 pounds to 8 pounds. Well, assuming there's no specials, no price discounts, no bulk that we're not at Sam's Club, we double the amount we buy. Matt, what do you think? Will that double the price? Why? Yeah, it's like buying another 4 pounds. So I could either think of it as doubling, or 4 pounds being 27, and another 4 pounds being 27. You do 27 plus 27. What would that cost? 8 pounds. If we double 27, what is that anyway? 54, right? So if you copy down this table, I'm gonna scroll. We can agree with Sonia. 27 doubled is 54. That works out. What do we think about if she's going on a trip, doesn't need to buy as much, taking the bird with her? No, she's feeding birds in the yard. What about 2 pounds? I hate that vibrate is still audible. Like, what's the point of vibrate if you can still hear it? Leanne, what do you think?
2 pounds is $13.05.
How did you get there? If I buy half as much as what I had bought, my price will be half. Fortunately, you can't buy half a pizza or things like that. But birdseed, if I'm going from 4 pounds to 2 pounds, my price is going to get cut in half. And that's $13, and I'm writing too large. And 50 cents, right? Yes, 50 cents, yeah. 0 pounds, we all talked about together. If you don't buy anything, you're going to pay $0. 3 pounds, how did you get there is what I need to know. Alan, there's a few different ways to get here. How did you get to 3 pounds?
To what?
How did you get the price for 3 pounds?
So what I did, okay, so I did 13.5 plus 6.7.
Yeah, we can take the 2 pound price plus the 1 pound price, add them together. There's another way though. Have we got the other way, Nathan? We can take the 1 pound price and triple it. which is what? 1975. So then, instead of like having to add things together, I can do that for any weight of birdseed. 5 pounds, what would I multiply 5 by? That 1 pound price of 6.75. What do we get for 5 pounds?
For number 3, I got 20.
Let's check the math. 6 times 3 would be 18.
Because if you add 75 plus 50 equals 75 plus
Sorry, what should it be?
it should be 20.25.
20.25?
Yeah. Yep.
Yeah, check the math. Easy to make small mistakes. What about 5 pounds? Once we multiply by 5, we get,
35.75.
wait, what? 30.75? And 6 pounds. For some reason, they skipped 7. 40 and 50 cents. Okay. So if we were to graph this, let's think about a simple graph. Go ahead and sketch one in your notebook. Now I'm going to show you the easy way to do this. Whether you have graph paper or line paper, if we know that these amounts start at 0, 0, and go up the same amount every time, we're going to cheat a little bit. And not really cheat, because cheat's a bad word. You guys, like, cheating is bad. Draw your axes, right? Your x and your y. So in your notes, draw x, y axis. Can my price go up without my amount going up? Can the price go up without my amount going up? No. So we say that price is dependent on the amount. Since the amount is independent, it's your x-axis, so we're going to put the amount of seed down here. Which means then over here, we're going to put dollars, how much it costs. Now here's where the we're going to cheat kind of, quote unquote, comes in. If you have graph paper, run a perfect diagonal up through your boxes. Mine's not quite perfect, so I'm going to fix that. Try to run a perfect diagonal. If you don't have graph paper, just draw a diagonal line. Start from the origin. Sorry, this should connect. Because we know $0 corresponds to 0 pounds. Now this is the part where I said we're going to cheat. My axes aren't labeled yet, right? If you're on graph paper, we're going to make our life easy. I'm going to go 2 boxes out and 2 boxes up. Or 1 box out and 1 box up. Or 3 boxes out and 3 boxes up. I'm always going to meet on these intersection points. If I buy 1 pound of birdseed and I go up to where it hits the line, then I go over to how much it costs, what should I label that part of the y-axis? How much was 1 pound, Alex?
75.
So that label, I'm just going to make 6.75. You don't have to use whole number labels. A lot of us get stuck on using whole number labels. If you know what the marked points should be, just label those numbers. What about 2 pounds? If I go over 2 boxes and then I go up 2 boxes, what's this label on the next one going to be? According to our table, 2 pounds is $13.50. Keep labeling so you at least go up to like 4 or 5 pounds. And you can skip if you want. You don't have to label every single one. So 5 pounds, I know corresponds, or actually 4 pounds is easier because I know it corresponds to 27. I could do 6 pounds. Yeah, that was 40, 50. Now, I want you guys, once you get this drawn, to talk with your group and find similarities and differences between the two graphs that we worked with. One that I gave you for the college fund, and then this one for our birdseed. What's the same on the graphs and what's different on the graphs? Probably only need a couple minutes. So we'll bring it back here in 2 or 3 minutes.
It also doesn't
While saying that one is birdseed and one is money, that's not what we're looking. Look at the graph, like what it looks like.
It looks like it's good.
Similarities and differences in what it looks like.
They're both
I'm out of food.
both of them are
great job. That was like all you were drawing in kindergarten.
both of these graphs represent a statistic.
All right, I've got the two graphs up on the TV. Now, their axis, they didn't cheat. They just labeled 10, 20, 30, 40, but we can label how we want. So, let's say same and different. Alan?
They're both linear. They're both like a linear.
Linear, which is a big old word that we don't totally know yet. What Alan really means is they're straight lines. That's what he means by linear. So please write that down if you don't have that. They are both straight lines. Grant?
Can I say one for the
Yeah.
our one on the right,
Yeah.
is proportional.
Ooh. So I'm gonna say trying to figure out how to write this. Proportional versus non.
Yeah.
How do you know that? I know I already gave it away earlier, but
It goes through the origin.
so we can label that as like intersection, where it intersects the y. So we actually call those the y-intersects or intersects. They're different, right? One goes through the origin, one does not. Anything else? So, here is what makes a proportional graph. Somewhere in your notes, please. And you can abbreviate it PropRel. Proportional relationship graphs. Need two things. No, I think they know. If we said that the one on the right is a proportional relationship, we identified one thing already. Goes through the origin, which is our 0, 0 point. So it needs to have, if you have nothing of the one thing, you have nothing of the other thing. And then the other thing is actually what was the same for these two graphs. has to be a straight line. If it only checks one of those boxes, if it's only a straight line, or if it only goes through the origin, do you think it's proportional? Nope. It needs both. Both of these things have to happen to be a proportional relationship. So if you see the graph, you can really quickly tell if it's proportional or not. So times they'll try to trick you, and they'll give you one of those. Say you have a graph like this. They'll start at the origin, and then they'll curve up. Or they'll start at the origin in a straight line, and then they change. Not proportional. It does not stay straight. It starts straight, but it doesn't stay straight. Or they'll even, and this is really nasty, they'll just change slightly, not proportional. It doesn't stay straight the whole time. Both of these sections are straight on their own. It's not straight the whole time. So be careful with those. Any questions? Preguntas? Let's help Carlos. Alright. So, our task. Work with our team to read each new situation below. Decide whether you think the relationship is proportional or not. So, please label A through F on your paper really quickly. We got about 5 minutes left. Should be plenty of time. Decide if it's proportional. All of you really need to do is agree with your team, yes or no. If you disagree, please raise your hand so Mr. Smith or I can come be the tiebreaker. For a video game? That's really cheap. That's cheap. Now I would never take that. And those concert tickets are pretty good price.
Yeah, they just handed their good spot. I think it's
About 2.5 minutes, so we'll pull it together real quickly. Yes, no, these. It's cute.
I hit it with my fist too. I was like,
About a minute. Are we good or do we need more time? No response.
Any more time, please?
Thank you.
Still on C. I don't think I'm ready.
All right, we have about 2 minutes. We're going to run through this quickly. I need to know yes, no, and why. All right, bring it back together. Marvin on A, what do you think and why? Yes, why? Each game, right? That price won't change. Each game, 36 bucks. Emma Browning, what about B? Why? But what about when he buys 5 for $250? Is that 5 times 56? There's a special price break at 5 tickets that is not proportional. B is no. Hey, why are we packing up? I'll wait. Wherever you're headed, they'll be patient. C, Delaney? C proportional? No, because it's a addition. Older than is addition, right? You're always 4 years older than. Alan, what about D?
Yes.
Yeah, a 7. Now, if they keep that pace, which it doesn't say anything about not. What about Carl loading 50 songs each week?
Yes.
Yes, and Aubrey, what about Anna and her video games?
I didn't get that far.
Who's got it?
No.
No, because level 2 is faster. Alright, I'm still releasing you ahead of time. So please don't pack up early. Have a great day, guys. Mr. Smith.